Hello, my name is Kelby Morgan. I'll be introducing our final project for programming for instrumentation at OSUIT. The project is a DCS system which will be controlling 2 trainers locally and remotely. Locally, we can control them manually and automatically, and remotely, we can control them automatically.
I'm Jeremy Hogue, and tank level was determined using a Rosemont pressure transmitter. The pressure transmitter was calibrated with a heart monitor, and the pressure transmitter sends a signal of 4 to 20 milliamps, 20 milliamps being full and 4 milliamps being empty. The 4 to 20 milliamp signal is represented in the LabVIEW program and converted to a percentage and also sent to the remote operator.
My name is Ken Crenshaw, and this is one of our 2 trainers which we use for the local mode of this DCS system. It is ran off 120 volts from the wall. We implemented an emergency power cutoff switch, which allows us to be able to kill power to the system at any time for safety measures. Next, we have a 24 volt DC power supply, which is also ran off 120 volts. That 24 volt DC generator is used to power the 2 relays which turn on and off the pumps for the tanks. Next, we have the RTU is consisted of a NI compact DAC chassis which houses our 4 cards. The first of being a NI 9203 analog input current card, and that card allows us to be able to read the 4 to 20 milliamps from the pressure transmitter along with the 4 to 20 milliamps coming from the radio which is sent to us from the MTU. The next card being a NI 9265 analog output current card, and that allows us to be able to send our 4 to 20 milliamps coming from the pressure transmitter out through the radio to the MTU. The next card is a NI 481 electromechanical relay card. This card allows us to be able to use a digital Boolean signal coming from LabVIEW to turn it on and send a signal to the radio, which will tell it to be able to receive and send signals from the MTU to the RTU. Lastly, we have the NI474 digital output card. This card sends a digital signal to each of the relays, allowing them to turn on and off, allowing the pumps to turn on.
Hello, I'm JD Dick, and I'm going to talk about the radio in the panel. The G308 wireless radio remote takes a analog signal from the AI1 input and puts it to the NI9265 DAC output, which takes a signal from the pressure transmitter and sends it to the MTU. It is wired from the power supply of the 24 DC power supply to the remote, and it is grounded through one of the DACs and grounded through the 24 volt DC supply.
Hello, this is Joseph Dooley. This is our front panel. Each station will be controlled and operated and monitored through a front panel, just like this. It will only be used in the local mode. Here it can be operated in either manual or automatic options, and will display height levels of each tank in percent full. When one mode or option is on, the other would be grayed.
My name is James Cairo, and in this project, the one way we were able to control the level of the tanks is the manual mode. And in the manual mode, we basically introduced 2 Boolean switches, 1 and 2, and when they are turned on, we are able to control the level of the tank respectively. Example. When we turn it off, the level stops. And on switch 2, when we turn it on, the level of the tank switch will down.
Hello, my name is Michael Nugent, and I will be displaying the automatic mode using lap view. Automatic mode is just another way of controlling the tank levels automatically. Now I will show you a brief demonstration. As I change my input level, the tank will begin to fill to the desired level and then will shut off once it reaches that set point. Once the tank is filled to this desired set point, it will not restart until the input level is changed.
This is my front panel for the remote control on the MTU. I have a display for the remote or local mode, which displays what mode each station is in. I have a set point slider that requires you to enter a password to adjust it. This will adjust the signal that is sending to the station. And then I also have the level displayed from 0 to 100%. How this is done is first data is communicated between the DAC and the computer via USB. All that data is then converted into analog signals, voltage, 420 milliamp current, and communicated to the CLIC PLC. The CLIC PLC, its only purpose in this circuit is to convert everything into serial data and then communicate it with the radio modem. The modem communicates with each slave independently. There's a 420 milliamp output, 420 milliamp input, and a digital input to this. What's happening is the set point here adjusts the analog output here from 4 to 20 milliamps, and that will tell them how full their tank should be, at 4 milliamps being 0%, 20 being full. The analog input to the slave here accepts a 4 to 20 milliamp input from their DAC, which tells the master what their tank is at. The digital input, if it is high from their DAC, the digital input on the slave is high from their DAC, it tells the master that it is in remote mode and allows set point adjustments to be made.